Hello. So this is my second video of this series of pendulum motion. So this is a pendulum. I made it with plastic ball and there is a thread by which it is hanging. So today I'll be explaining what are the basic assumptions are taken for a simple pendulum. Basically, pendulum is a object which can be oscillated in any period, so it can be very complex also. Mostly it's called compound or physical pendulum, so like any object, so it can be a pen, so oscillate like that, or it can be like my water bottle, so it can oscillate from a pivot like that, so we can find the time period of it. So but here today I will be talking about only simple pendulum. So what are the assumptions are taken for a simple pendulum? So this is a model of a simple pendulum. So what are the features of it? So one thing is considered is this pendulum has a bob, so which is a mass, so it's an object of mass m. So its mass is concentrated at a center. So let's say it's a spherical ball here, and mass is concentrated at the center of the sphere. So this is one assumption. Second assumption is the string by which it is hanging, it is massless. So that is another assumption. And length of the strings are considered from the pivot point here to the center of this ball, because mass is concentrated at the center. Third assumption is the string is unstretchable. It's not like spring or any elastic band. Also, it cannot bend like this. Okay, so physically it should be a rigid body like a wire which doesn't bend but still massless. Why so? Because for small angular motion like kind of this oscillation, it doesn't have an issue. It will follow a circular arc. But when I have a very large angle like greater than pi by 2, so instead of following this circular path, what will happen? It will kind of fall apart, right? So it doesn't follow that circular trajectory like circular arc, because that due to gravity it just fall. So it doesn't have provide the tension to keep its hold. But for this position, like what will happen, the arc is circular but it try to fall like this. So but it cannot fall because I am holding here, so the tension is supplied, so that's why it follow this circular arc. But for a string which cannot have this bending of this thing, so it's rigid but still massless, it can have full swing. So that ideal scenario I am talking about. Also here I am considering the back and forth motion of this pendulum happening where air resistance is negligible. What does it mean? So it has a mass m, so when it's having movement it will have a kinetic energy. Also, as it is changing its height against the gravitational acceleration, so gravitational force, so it will have gravitational potential energy. So total energy would be kinetic energy plus potential energy. So if there is no damping because of the air resistance, so what will happen? Energy would be conserved. So we will be talking about that scenario, simplest case. Another thing is that here the pivot point, it is considered it is also not moving. So if I move my hand, okay, then degrees of freedom are increased, and also the motion is becoming more complicated. So we are not talking about that motion of the pivot itself. So pivot is fixed, then it is moving. Another assumption is taking for simplicity. It's not having motion like this, like in 3 dimensions. So we are restricting the motion in a 2D plane. So with all these assumptions, next video I will be discussing about its solutions, equation of motions, and the time period for a small angle. So hope you will connect with me in the next video.